Hello everyone, thanks for giving me this opportunity. My topic today is the transient impacts of Arctic storm on sea ice regional and seasonal analysis. Arctic storm activity has increased over recent years, and the previous study also found that sea ice accompanied with this increasing storm activity, sea ice rapid decrease. Statistic evidence have shown that the potential linkage between this increasing storm activity and decreasing sea ice. Storm case study also shown that storm may potentially facilitate sea ice melting. And in this study, we try to focus on the scientific question, which is over different locations and time of year, how do storms impact on sea ice? And what are the storm's short-term, mid-term, and long-term impact on sea ice? So, as an example shown at this well-known storm case study, at different stage of the storm over same location, the storm can induce both the warm air advection and cold air advection, causing increasing sea ice and decreasing sea ice. To combine those storm cases, we developed a new composite analysis. In this analysis, we define a composite analysis domain, which is over selected locations with sea ice coverage along the storm track. Because the composite domain is along the storm track, it allows us to monitor the sea ice changes before and during and after the storm passed our composite domain. So as shown by this schematic figure, the circle with a solid line represent the location of storm, and the circle with dashed line represent the location of a composite domain. So when the center of the storm coincides with the composite domain, we define the time t lag equals to 0, and t lag is negative, represent the time is before the storm arrives, and t lag is positive, represent the time storm has passed the composite domain. So if we look at the results from this composite analysis, here I listed two examples. The top figure shows the Central Arctic, and the second figure shows the peripheral sea, which is the East Bering and Laptev Sea. So as you can see from the bottom figure, as storm approach to our composite domain, it gradually causes sea ice decrease. And after the storm moves away, the sea ice gradually recovers and increase larger than the climatology. And quite differently, over the Central Arctic, storm can cause continuously sea ice decrease. And you can see the sea ice area is less than the climatology. And we found, according to analyze those energy budget term, we found because the storm penetrates through the peripheral seas, as they move northward, they will cause cold air advection and increase the sea ice area. But since the storm track generally tends to go around the Central Arctic, it will continuously transporting warm air into the Central Arctic. That causes continuously sea ice decrease. And that's all I have today. Thank you so much for your attention.